My name is Arno Dubois from Silverstream Technologies, and today I want to take you through. I want to take you through Silverstream Technologies' journey in the CHEK project. So I'll discuss a little bit of who we are, what Silverstream does, and the Silverstream system, our product, our CHEK journey, past, present, and future, and then hopefully have some time for Q&A as well. So the Silverstream system is an air lubrication system. What is air lubrication? Well, air lubrication is the deployment of air to reduce the frictional resistance of a ship. As everybody knows, air is much less frictional, less dense than water. So introducing this in the boundary layer of the ship will reduce the energy consumption of the vessel itself. Our system is deployed in the flat of bottom, so really talking about reduction of the flat of bottom of the vessel through a uniform carpet of air bubbles. What does it do? Well, we reduce the energy consumption of the vessel. So really looking at contributing to shipping decarbonization by reducing the fuel consumption, and as well as having a significant financial impact on the vessel's operation through this reduction of energy and the reduction of the fuel cost that comes with them. Very important, this aspect is the fuel agnostic perspective of this all. Independent of which fuel you're using, air lubrication allows you to use less of it. This is very important if we look at transformational fuels, which are likely to be less energy dense. You'll need more of them and more expensive than traditional fuels. So it's really about saving energy rather than directly saving fuel. And this is something air lubrication can help ship owners and ship operators with. The Silverstream system is a quite unique system in the air lubrication world, but I'll talk about that in my next slide. But mainly it's a very simple installation, ready, available for new build vessels as well as retrofits, and can be installed after consideration during new build stage or during a regular dry docking period of a vessel. It's a fairly simple and robust installation process as well as concept, and is complementary to other technologies, which CHEK is part of, showing this with for example, wind assisted ship propulsion. It's about saving energy as well as transformation of fuels, again, complementary with these sort of technologies. Our technology is independently verified by a number of parties that you can see on the slide and consists of 4 main components. The brain of the system is the automation system that turns the system on and off depending on the start-stop speed when positive savings can be realized. We're always talking about net savings. So something what the ship operators, for example, a chief engineer on board of a ship would always tell to me, saying like, why would I turn your system on? When you turn your system on, I see my auxiliary engines using more power. Well, that is because we're talking about net savings. We are saving more energy than we use. We're creating a net advantage for the ship owner and operator. This automated system is what keeps track of that. It will change the amount of air that we produce, that we use depending on the ship's speed and draft. What does this automation system drive? Well, it drives a set of compressors generating compressed air through a piping system and a set of valves. Important for this, that this piping system is a passive system, so we're not actively controlling the air through the piping system. The only driver and control of the airflow itself is the compressors, who are variable speed drives. They then end up in what we call the air release units. That's really our core technology, a patented product, and that is where the air is generated to create this uniform bubble carpet. So when we go into this air release unit, is really the unique aspect of Silverstream is the way we generate that air. So rather than injecting air into the boundary layer, disturbing the boundary layer and potentially the flow field around the vessel, we create this field through a concept called Kelvin-Helmholtz, where we generate a fluid shearing effect. So what you need to imagine this air release unit is as a pocket inside the ship hull, which we fill up with air, where you create a small surface, free surface underneath the vessel in the hull, where water flows past, dragging this air into the water, into the boundary layer where it belongs, where it's needed to reduce the frictional resistance. What is the benefit of this? This is much lower energy requirement. The only pressure differential we need to overcome with the air is the hydrostatic pressure, getting the air down to hydrostatic pressure at the draft of the vessel. Then the Kelvin-Helmholtz effect takes over and produces these very high quality micro bubbles for us. As I said, the relationship between the airflow and the vessel speed and draft is what's key behind driving this physical principle. And all our testing, all our fundamental research is done at full scale at HSVA's high-cat cavitation tunnel. So often a comment that we get from customers or what in discussions is, well, have you done model tests? Of course, in a model test, you can scale according to Fruit or Reynolds, but the problem then lays is, how do you scale air itself compared to these two? You can't scale both your fluid flow of the water and the air at the same time. So model tests are kind of out of the question. When we look at CFD, another question arises, how do you validate this? You've got micro bubbles, maybe 1, 2, 5 millimeters big, compared to a vessel of 400 meters. And anybody doing some numerical modeling knows that getting that resolved in your grid, in your numerical discretization is pretty much impossible using current technologies. So that's why we do full-scale modeling. We place one of our air release units in a cavitation tunnel. So that's a unit 4 meters by 1 meter wide. In this massive tunnel, looking into how the drag is reduced, how we can then take these learnings onto the actual ship. So when we see the Silverstream system in action, this is what you see in the wake of the vessel. It's fun to go on board and see the crews and anybody who hasn't seen the system standing on the aft of the vessel, turning the system on and seeing this stream of bubbles appear. What you see in the bottom is a picture of our testing at the experimental facility, and that is this cavity, this free surface formed, and this carpet of bubbles being released from the air release unit. It doesn't show on pictures and it doesn't show on camera, but when you're there at the facility and you see this effect occurring, that is really where you see this silver stream occurring, also referring back to the name of the company. So what does this do with the ship itself when it's operating? Well, as soon as you turn the system on, your ship will start to settle in a new state. The frictional resistance of the flat bottom is reduced, your shaft power will go down, and your shift speed will go up. Using these two, relating these 2 kilowatts in energy, you can calculate your gross savings, subtract the energy used by the compressors, and you get the net savings, the advantage provided by the Silverstream system. This is MSC Loreto, a 24,000 TEU container vessel that was commissioned early last year. I was actually on board of this vessel in China during the sea trials. Quite impressive to see, especially when it's unloaded and sits, of course, much higher in the water. And that was really one of the key projects that we've been developing, these massive MSC container vessels. Gives an overview of our 196 total projects. It's really about building up knowledge, building up this team, and really delivering a scalable decarbonization product. A little overview of what these 175 projects are. Majority in the container vessel market, ranging between 8,000 and 24,000 TEU containers. Gas carriers, prime example of an ideal vessel type to install air lubrication on. Ro-ro vessels with the Grimaldi group in the Mediterranean. Combination carriers and the cruise market as well. We also have one VLOC. So what did Silverstream do in the CHEK project? Well, unfortunately, we didn't manage to do a full-scale actual physical installation during this project, but CHEK was for us about demonstrating how the design, installation and operation of the Silverstream system can happen in symbiosis, really providing knowledge to our partners, to ship owners in this vessel profile, how this business case for air lubrication can be made, how it's technically possible and economically viable. Silverstream system was applied to both vessels, both the cruise ship as well as the bulker. And we did some experimental work towards lower ship speeds, because you can imagine bulker vessels operate at a much lower speed profile. If you then again add wind sails providing most of the propulsion, speed goes down. How can we make sure that these technologies work together? And I think our dream scenario in the future is working more with these kind of partners to actually get a physical installation of wind together with ALS. And in my dream scenario, proving that 1 + 1 can indeed be more than 2, although the mathematicians might disagree with me. The innovation part of Silverstream in the CHEK project really came from the bulker case in this low speed through this experimental research. as well as a novel compressor approach. So in our traditional system, we operate a system of one compressor with 2 ARUs. Bulkers, lower speeds, lower savings in absolute numbers, so longer return on investment time, so you want a cheaper system, and a system that takes up less space on the vessel, so lower capex as well as opex, and that is possible through what we developed here is a 1-to-4 solution where we operate one compressor with 4 ARUs. First deployment of this kind of system actually happened during the period of CHEK with one of our customers. For the future, CHEK really showed us that there's value in research. We can push ourselves forward rather than just selling another one of our existing systems, and it's about working with other people. So we really want to make a continued effort in this innovation, research, and development space. We want to be an innovator, we want to be a thought leader, but we also want to generate deeper understanding of the technology, of the physics behind air lubrication. For example, next week I'm attending a workshop that's really about air lubrication on its own, together with technology providers as well as universities. It's really a topic that's not necessarily understood. We know it works. The whys behind it are still debated, and that's really what we want to push forward to bring this and scale this up even further. We really learned that collaboration between academia and industry is possible, so we can learn from each other. As well as EU projects are worthwhile participating in. There's some new calls for Horizon 2024 that we participated in, for example, in the URN mitigation space, outcomes to be decided later this year, as well as technology integration and uptake that's really important. For people interested, there's a QR code on the screen. I can pop it up at the end again, which leads us to our academic resources page on our website if you want to learn some more about the more science behind the technology and the research work we're doing. Another part is that we also know that customer and crew engagement is key in the uptake of any technology. It's the people on board that will have to operate the system. The system needs to be safe, well understood, easy for the crews to handle, and that will be key going forward into the automation space as well. When the crew doesn't understand the system, does not want to use it, they will not use it, and then you might as well have not installed it at all. There's a range of products and spaces that we want to explore further. I think the product space itself is really developing things for market. It is very important to us. Performance quantification, some of our partners in class as well as customers, there's a lot going on in how to prove energy efficiency technologies in the market, in service. For example, DNV is working on a new index. That's very important to push the industry standard forward and take these into account and prove these things to the market so the uptake can really accelerate and fulfill its full potential. There's the numerical modeling space that I was talking about, still a very big challenge. Interaction with fouling and anti-fouling products, for example, with the paint manufacturers, again, about symbiosis, how can we bring these things together? Other energy efficiency technologies, for example, wind, and I think AI, machine learning, that whole space is really booming. There's so much more possible these days. And with this, I also want to extend an invitation to anybody here. If you want to collaborate further, please get in touch. Please have a chat with me after this. I think this project on its own has shown how collaboration can really improve the global space of decarbonization, the maritime industry, as well as a company itself. Thank you.